Okay, so the first climate dog that we're going to meet is Sam.
Meet Sam. Sam herds cold fronts up from the Southern Ocean, a significant source of rain for much of southern Australia. If we take a look at the Southern Ocean, we can see westerly winds roaring around Antarctica, throwing out cold fronts of stormy, wet weather. The strength and position of these winds is known as the Southern Annular Mode, or SAM. SAM is an unreliable climate dog, often changing behaviour over a matter of weeks. This can affect southern Australia's rainfall in winter, and even parts of eastern and northern Australia's rainfall in summer. When SAM is tied up, strong winds are pulled south towards Antarctica, and there is a reduction in the number and strength of cold fronts that reach southern Australia, reducing winter rainfall. When SAM is let off the leash, this can drive westerly winds further north, increasing the chance of cold fronts and rainfall across the southern states. But in summer, SAM acts a bit differently. If SAM is sitting further south, it can actually coax more moisture and summer rain over parts of eastern and northern Australia. SAM's behaviour is complicated and is linked to what the other climate dogs are up to. However, over recent decades, SAM has been tied up more often, resulting in fewer cold fronts and less cool season rainfall for parts of southern Australia. Scientists are watching this climate dog closely, hoping to tease out how it may impact our weather and seasonal climate variability down the track.
Okay. There's Sam. You'll see a lot of information very sort of quickly in these videos. So, okay, here's the next one we're going to go to. Who have we got next? Reggie. Okay, everyone ready for Reggie? Pens at the ready?
This is Reggie, or as scientists like to call him, the subtropical ridge. Reggie is one of the major drivers that shape southern Australia's weather. So let's look at how he does it. As warm air rises in the tropics, moves south, then cools and falls, large areas of high pressure are created. This band of high pressure, in this case Reggie, is great at blocking rain-bearing fronts. From November through until April, Reggie chases away cold fronts around southern Australia for days or even weeks at a time. When winter sets in, Reggie heads north, and cold fronts find it much easier to reach southern Australia and deliver their rain, until Reggie returns again next November. Reggie travels north and south every year, but in recent decades he's been getting more effective at chasing away cold fronts from parts of southern Australia, meaning more dry weather and later autumn breaks. The Bureau of Meteorology has observed that Reggie's increasing strength is related to the rising global average temperature. But the scientists are continuing to investigate how this climate dog might change his behaviour in the future.
There we go, some pretty good links between what Graeme was discussing there, of course, lots of rising temperatures and the strength of Reggie. So that's an interesting one. Okay, now we're going to listen to the third one. This is the last one.
This is Eastie, better known as the East Coast Low. Eastie represents the deep low pressure systems that are an important climate feature along the southeast coast of Australia. These deep low pressure systems can be caused by upper atmosphere disturbances, decaying cyclones, existing low pressure conditions, or in the wake of passing fronts. Scientists have found that Eastie tends to have a mind of his own and can be quite hard to predict. This energetic little dog can be triggered into action overnight, causing strong winds, big surf, heavy rains and lots of rough weather. Eastie can appear all year round, but typically prefers the seasons of autumn and winter. Even one-off events can dominate a region's annual rainfall tally, explaining a lot of the seasonal variability east of the Great Dividing Range. Eastie usually cares little about what the larger climate dogs are up to. However, scientists have noticed that Eastie can be a bit timid when Reggie, with his high pressure, is around. Scientists continue to look into Eastie's behaviour. In the meantime, we'll need to keep a close eye on this powerful little dog, especially when he's sparked into action.
Okay. So that's the 3 climate dogs that we're going to focus on, and there are more. And you can have a look at the Climate Kelpie YouTube page to see more about the climate dogs and learn a bit more about them. And you can see how it's a really great way of almost putting a face or putting a character behind those climactic conditions. It can be a little bit harder to understand. So what we're going to do now is try and apply a bit of what we learned then to some farming scenarios and see if we can pick out the climate dogs that are affecting the specific climate for these particular people. So scenario number 1, Joe the canola farmer is waiting on his regular autumn rain to plant his next crop, but every time he looks at the rain forecast, the chances seem to dry up. Joe's father and grandfather, both farmers in the region, they told him that wet weather will always arrive in autumn and signal that the best time to start planting winter crops. So if you guys could just have a little think, in a moment I'll ask the teachers if they could unmute and just get one student, I suppose, to be the spokesperson for each classroom and just say what you guys think. So just have a think about Reggie, Eastie and Sam and what you just heard, and think about what could be causing, I suppose, rain to appear on the forecast for Joe, and then for those chances to go. So that weather system that's there is being pushed away somewhere else. Remember that it's autumn is the time of year that we're looking at, and I think we're seeing possibly some climate change impacts here because we're talking about weather that people traditionally have said happens every year, and it's not happening this particular year for Joe. So I'll give you guys a couple of minutes to think, and we've got Graeme here, of course, to discuss your answers because he's the expert. So I'll let you guys have a think for a couple of minutes. Feel free to discuss it between you. Okay, that might be long enough now. Let's start with Mafra. If you could just unmute your microphone there, and if the student could just say their name and let us know what they think, that'd be great.
Hi, Amy. I'll pass it over in a second. It is unanimous here at Mafra.
Oh, great.
I'm Jeremy, and I think that it is Reggie that's causing the problems, and ways to adapt would probably just be planting the crops regardless that it's not happening. So that annoying does come already.
Did you hear that, Amy?
I got most of, did you get most of that, Graeme? I think you were saying Reggie, is that right?
Right.
Okay, what do you think, Graeme?
Yeah, great answer, well done. And Reggie's got a role in sometimes autumn breaks that farmers talk about it, which is the start of the winter season. When we look at them from say 1950 to 1980 and then compare what's happened since 1980, there's actually that higher pressure has meant that we're getting those good autumn breaks less often. They still happen, but there's just bigger gaps between them. Farmers wish they were behaving like they used to. So that's a great little example of Reggie doing his thing.
Great, thanks Mafra. Let's go to Nagel now. What do you guys think that Joe could do to adapt to the situation? So I wonder if you could think of any, I suppose, ideas for what he could do to get around the problem that the rain's just not arriving at a time that he's used to it.
Plant some dry weather crops, keep away from cotton and any of those water guzzling crops.
What do you think, Graeme?
Yeah, well, there's been a lot of work done on, especially for the winter cropping, plants that are more efficient with water. So, and it's interesting, we've shown over the years that per millimetre of rainfall, farmers can grow a lot more wheat and barley and lentils than what they could 30 years ago, just because they've got better varieties. So that's one. And the other one is farmers are actually, they've been doing a lot of things like conservation tillage, which is where they do a lot less ploughing of the soil, and actually, because the soil's a bit healthier and all of the residues and stubbles from the previous year's crops are there, it actually means there's more moisture. And they have, when they sow the crop, they have a little press wheel that comes along and leaves a little ditch where the seed's placed. And so even with a little bit of dew or only a tiny bit of rainfall, that falls straight to where the seed is. So they've been doing all this sort of stuff that tries to help with these much drier autumns.
So let's move on to scenario number 2. So West Gippsland celery farmer Suzie is watching the skies, hoping for heavy rain to fill her dams so she can irrigate during the summer months. Suzie usually gets more than enough rain over winter and spring to have her dams overflowing. But this year she's watching the bomb radar and storms almost get to her farm and then they get blown out to sea. So similar situation, different scenario, but we're going to ask the same questions. We're going to talk about if you could all think of what climate dog or climate dogs are, because it could be a couple of different influences that are affecting this farmer. Who do you think the climate dogs or dogs are? And also, what do you think Suzie could do to adapt to this problem? So if it's something that keeps happening, she might need to think of a way to get around it. What do you guys think? Great, we're getting some responses coming in on the chat log, which is great. Wonthaggi Secondary College has said for this one, Sam and Reggie. But let's start with Nagel 1. So,
hello, we don't know.
Look, we don't know, but we do know that we get that that condition all the time, particularly in the last couple of years in Bairnsdale. The weather would come over and it would look like, oh, we're going to get rain, but then it would all go south into the Bass Strait and we wouldn't get any of it. And that was basically the cause of our drought over the last few years.
Yeah, a very frustrating thing, right, to happen, to see that rain on the forecast and on the radar, and then it just doesn't happen.
And then the only time we would get rain was when there'd be an east coast low, which we haven't had many of that have made it to Bairnsdale in the last couple of years either.
Yeah, well, great that you guys can identify that it's happening. Let's skip over to Mafra. I know that you guys have picked 2 different climate dogs that you think are affecting this situation. So if someone could just jump up and explain why you think that.
We didn't nominate a speaker, but I'm happy to. Reggie was shown in that animation before to just push things quite far south, but I believe it said more so that Sam is responsible for the wet weather being pushed to that South Gippsland area. So it could have been both, but we were thinking mostly Sam.
Mostly Sam. What do you reckon, Graeme?
Yeah, good answers. Yes, that's right. Because for winter rainfall, and often with that, the runoff that we get in winter, spring, it's, the soil's wetted up, but it's rain in that period, which really helps fill up our water storages. And so some of those seasons where Sam's sitting a bit further south means that we just don't get that extra couple of rain triggers coming through. But also Reggie and Sam have a bit of a battle, really. Like Reggie's trying to push Sam south and Sam's trying to come through. So both of them have got fingerprints on that dry winter. And also for East Gippsland, it's really interesting for that previous 3 years, that Eastie to come in and bring some of that easterly and southerly flow. Eastie is always a good circuit breaker, which sort of can come out of nowhere and bring some big rain events. And for the last couple of years, Eastie's just been not very active. So they're all 3 are playing a bit of a role.
How interesting. And Nagel too, you guys come up with a really good suggestion for an adaptation that Suzie could do to try and utilise whatever rain she is able to capture. Would you guys be able to unmute and turn your camera on? And if one of the students could just explain that idea that you guys typed into the group chat, because I think it's a really great one.
Here comes Oliver to participate. They've just had their morning tea provided. Thank you so much, Amy. And say hello.
They've already heard me. I've said it 5 times.
Say hello.
Hi.
And we okay, so Oliver, what we're doing is we're putting in irrigation.
Putting in irrigation.
And we're trucking in some water in it.
And chucking in some water. What else?
Well, what else do you think? How else are we going to get around this lack of water on this celery farm? So we're going to ship water in trucks, or truck water in. We thought that irrigation, and we used the scenario of somewhere like Maffra or Shepparton and Echuca, for those that might know that area, that are solely pretty much reliant on irrigation. So we use that scenario locally. Maffra, areas of Sale that have irrigation channels. We thought that would probably be the best option. Didn't we, Oliver?
Yeah, I thought it was the best one.
Thanks, Oliver. What do you reckon, Graeme? Is that the sort of thing that farmers are talking about and utilising?
Exactly. No, that's spot on. And we even see like in our irrigation areas where what used to be shared water in open channels, and often I find that, you know, if you release 100 litres of water at one end and put it through open channels and drains, you can lose more than half of it for evaporation or seepage. So there's a lot of work where people are putting more of that into pipes, which saves a lot of losses. But also we see on farms where they're doing things like using finer sprinklers or drip systems instead, especially on some of the veggie farms, and also technology such as soil moisture monitors, which tells them, even though the surface might look dry, if there's moisture underneath, then they don't need to irrigate. So some of those using ag technologies and moisture probes in the soils is giving farmers a better idea of saying, no, you don't have to water yet, just wait for a few more days and then you can start watering. So all those things are all helping to save water.
Great, and that's actually a really great spot to leave this activity, because our next session is going to be with some real farmers, some people who are personally making those decisions to whether it's invest in irrigation infrastructure, which we know is like a very expensive thing to do, but in these situations like Susie's situation where you're not getting the rain you need, like Graeme said, these decisions need to be made. So thank you so much for your time today, Graeme, for your presentation and for staying on for our activity.